Hello students, welcome back to my channel. This is the second video in continuation with other videos. We are discussing questions which were asked on 31st of January, both shifts together, 2023 JEE mains. Okay, so let us continue with that. Coming to question number 6, as you can see, 100 balls each of mass and moving with speed v simultaneously strike a wall normally and get reflected back with the same speed. So in time t seconds, total force exerted by the balls of the wall. This question is based on Newton's second law. Okay, Newton's second law states that the rate of change of momentum will be proportional to the force applied. Okay, and here probably we are proceeding in SI unit, so that the total force is not only proportional, it can be taken equal to the rate of change of momentum. Again I am repeating, in SI units, force itself is taken as the rate of change of momentum. So perhaps we have to proceed in SI units. Okay. So let us find the rate of change of momentum. First we will find the change in momentum and we will divide by time t to get the rate of change of momentum. So first let us try to understand what is happening here. A ball comes, okay, say a ball of mass m comes with a speed v and it rebounds with the same speed v. Now change in momentum, okay, will be mv minus mv. I'll take the mod, okay. You can take either of the two directions as positive. For example, if you take the final direction as positive, this one as positive, then this should be negative and vice versa. So anyway, the end result should be 2mv mod. Okay. So there is a change in momentum for each ball. Now, as you can see, 100 such balls strike. So total change in momentum will be 100 times of change in momentum pertaining to each ball. So this is equal to 200 mv. Okay, this is the total change in momentum. It takes place in t seconds. So rate of change means what? Change in momentum in 1 second is known as rate of change of momentum. So therefore, rate of change in momentum will be equal to change in momentum, which is 200 mv, divided by t, and this is equal to force in SI unit as per Newton's second law. So correct option is the D option. Moving on to the next question, students. A body of mass 10 kg is moving with an initial speed of 20 meters per second. The body stops after 5 seconds due to friction between the body and the floor. The value of the coefficient of friction is. This is a very simple question. Now suppose a body is going with a, let us say, speed u, okay, and frictional force opposes its motion, okay. So finally it stops. Let us say the final velocity becomes 0. If you start counting the time from here, sorry students, let us say at the end of time t it stops. So we can find the retardation produced due to the friction. So as you know, v is equal to u plus at. If we apply this, then we have 0 is equal to u minus a into t. Okay. So required acceleration is u by t. Retardation is u by t. Now if you draw the free body diagram, you will find that the weight is balanced by the normal reaction. Okay. And the frictional force, which is also the kinetic friction or the limiting friction, here it is mu into normal reaction. So normal reaction is mg, because normal reaction will balance the weight for vertical equilibrium. So therefore, the numeric value of retardation is force by mass. Here you can see force by mass is mu into g. So always remember, retardation due to friction is mu into g. So retardation due to friction is mu into g. This formula you can memorize, which will be helpful again and again. Okay. So let us substitute the values here. as you can see, the initial speed is 20 meters per second. So I'll place 20 here. Then you have time taken is 5 seconds. So I'll put it 5 here. We have to find the value of mu. G has to be taken as 10. So 1 0 gets cancelled. And we are left with 2 by 5, that is 0.4. 2 by 5 is 0.4. Moving on to the next question. As shown in figure, you can see the figure. I'll slightly show the figure this side. You can see. As shown in the figure, a 70 kg garden roller is pushed with a force of 200 Newton at an angle of 30 degree with the horizontal. The normal reaction on the roller is. This is very simple. You have to draw the free body diagram, students. Then finally, you have to resolve all the forces along the horizontal and vertical directions. Once you do this, then it's a matter of just a simple calculation. So I'll draw the free body diagram here itself. It is given that it is a 70 kg roller and G is 10. So weight must be 70 into G, that is 700 Newton. This is the weight. Then you have normal reaction here. Now this F should be resolved along horizontal and vertical directions. Okay, along the horizontal direction it is F cos 30 degrees, whereas along the vertical direction it is F sin 30 degrees. Okay, now we are least bothered whether the roller is moving or is it at rest. We don't want to know that. But one thing is sure, that it has to be in the vertical equilibrium. Okay, vertically neither it is going up or down. So for considering the vertical equilibrium, for vertical equilibrium, I can write the upward force N must be balanced by the downward force, that is the component of weight, vertical component of weight plus the weight. Sorry, the vertical component of this force, vertical component of the applied force plus weight. So applied force is how much? 200 Newton. So 200 by 2 is 100 and this is 700. So finally you have 800 Newton as the correct answer. Correct option C. Then moving to the next question. At a certain depth d below the surface of Earth, value of acceleration due to gravity becomes 4 times that of its value at a height 3r above the Earth surface, where r is the radius of Earth. The depth d is equal to. So this formula is based on the variation of acceleration due to gravity with the depth and with height. Both are two different formulas, even though in either case G will reduce. G is maximum on the Earth's surface. As you go up, it reduces, as well as you go down, it reduces. But the formulas are two different formulas we have. So let us explore those formulas and then we'll try to find out the answer. Okay. So here I am drawing two different two Earth for two different situations. Okay. Right. So here, as per the question, there is a point at a depth d. This is the point. And then there is a point at a certain height h above the Earth's surface. Okay. So I'll take the acceleration due to gravity here as GD and here as GH. Okay. R is the radius of Earth, that is clearly given. Okay. Now the formula says G at a depth d is given by, if you take G naught as the acceleration due to gravity on the Earth's surface, then it is G naught into 1 minus d by r. You should memorize this formula, students. Okay. Similarly, if G naught is the acceleration due to gravity on the surface, then G at a height h is given by G naught into r upon r plus h whole square. Okay. This is the exact formula. As per question, the acceleration due to gravity at a depth d is 4 times that of its value at a height 3r. Okay. So we have been given that g at a depth d is 4 times g at a height h. In other words, let us bring the expressions. Remember, h is 3r. When you put h as 3r, so this will be 4r. G naught gets cancelled, 1 4 gets cancelled. Then we are left with 1 minus d by r is equal to 1 by 4. Therefore, d by r is 1 minus 1 by 4, that is 3 by 4. So, d is 3/4 of radius. If you substitute the value, radius of earth is given as 6400 kilometers. So, 6400 kilometers. So, 4 1600, 1600 into 3 is 4800. So, the correct answer is the B option. Moving to the next question. Spherical insulating ball and a spherical metallic ball of same size and mass are dropped from the same height. Choose the correct statement out of the following. Now the different options reads time taken by them, okay, to reach the Earth's surface will be independent of properties, etc., etc. Now students, even though I have taken this question in this chapter, but actually it should be taken in the chapter which is electromagnetic induction, because the concepts involved are based on electromagnetic induction. As you know, Earth is surrounded by a magnetic field. Okay. Now, when you drop a ball, metal ball, or any ball for that matter, it has to cut the magnetic lines of force. Horizontal component will be there. Earth has two components, horizontal and vertical. So when it falls vertically, probably it is cutting the horizontal component of Earth's magnetic field. In such a case, when it cuts the magnetic flux, when a metal cuts the magnetic flux, EMF will be induced and eddy currents will start flowing in it. So these eddy currents will start generating heat. As they generate heat, there will be a loss of kinetic energy. In other words, the retarding force generated due to this will bring the body close to the Earth's surface sooner than the case in which no EMFs are induced. So probably the situation in case of insulating ball and a spherical metallic ball will be different. Got the idea? In case of insulating ball, probably no EMF is induced, no eddy currents are produced, and there is no dragging force. Whereas in case of metallic ball, there will be induced forces. So that a stone of mass 1 kg is tied to one end of a massless string of length 1 meter. The breaking tension of the string is 400 Newton. Then the maximum linear velocity the stone can have without breaking is. Now, as we all know that for a mass m moving with the speed v, the required centripetal force will be provided by the tension, which is mv square by r. So as you can see that tension is mv square by r, and there is a maximum limit to which tension can go, and accordingly there is a maximum limit to which speed can go. Since v is in the numerator, so you can see the tension will be maximum corresponding to a certain maximum velocity. So let us substitute the values. So maximum tension is nothing but the breaking tension. Okay, tension which is permitted, maximum tension is this. Mass is 1 kg, V max square we have to find, radius is also 1 meter, that is length is the radius here. So therefore V max square is 400, so V max is square root of 400, that is 20 meters per second. So first option. Then next question, a lift of mass 500 kg is descending with a speed of 2 meters per second. Its supporting cable begins to slip, thus allowing it to fall with a constant acceleration of 2 meters per second square. The kinetic energy of the lift at the end. So suppose this is the lift, students. It is already moving with a speed u, and During its downward journey, it picks up additional speed because it has an acceleration of 2 meters per second square. So as it moves a distance 6 meters, we can find the additional velocity gained. So since this is acceleration is constant, so we can apply equations of motion. So applying equations of motion, we have v square equal to u square plus 2s. So v square is equal to 2 square plus 2 into acceleration is 2 and displacement is 6. So 4 plus 24, that is 28 meters square per second square. Okay. So we require the kinetic energy of the lift at the end of the fall. So the required kinetic energy will be half mv square. Half mass is how much? Mass is 500. 500 can be written as 1000 by 2. And v square is in SI unit 28. So as you can see, 4 sevens are. So this basically is 7000 joule. Since 1000 is kilo, we can write 7 kilojoule. So the correct answer is 7. Moving to the next question. A solid sphere of mass 1 kg rolls without slipping on a plane surface. Its kinetic energy is this much, the speed of the center of mass. If v is the speed of the center of mass, okay, then the total kinetic energy will always be equal to the sum of translatory plus rotatory kinetic energies. Is it? Now, translatory kinetic energy is simply half mv square, whereas rotatory kinetic energy is half I omega square. Okay. Now here, remember we know the mass and we have to calculate the speed. So we should be able to express the entire thing in terms of mv square. So let us write moment of inertia as for a solid sphere about an axis passing through its center, that is about any diameter, it is 2 by 5 mr square, and since it is rolling without slipping, omega can be written as v by r. So finally we have half into 1 plus 2 by 5 mv square. Okay, so finally we have 7 by 10 mv square. If you can memorize this, that's well and good. Otherwise, this is the way you are supposed to calculate. Okay, so this is given as 7 into 10 power minus 3 joule. We'll be substituting in SI unit everything. Mass is 1 kg, v square. So v square is 10 power minus 2. Okay, therefore v is 10 power minus 1 meters per second. 1 by 10 meters per second. Since the options, the answer should be expressed in centimeter, let us express meter in centimeter. So 1 meter is 100 centimeter. So this will be 10 centimeters per second. Correct answer is 10. Moving to the next question. A ball is dropped from a height of 10 meters. If the coefficient of restitution for the collision between ball and floor is this much, after hitting the floor, the ball rebounds to a height. Suppose the ball is dropped from a height h, okay, and it strikes the floor with a speed u. Let us say it rebounds with a speed v and rises to a maximum height small h. Then we know that u is equal to under root 2 capital H g, and here v is equal to under root 2 g small h. We also know that the velocity, the speed with which it rebounds is equal to e times the speed with which it strikes the floor. Okay. So here we can write root 2g small h is equal to e times root 2g capital H. Now in order to eliminate square root, we can square both the sides. Okay, so this is the formula. So coefficient of restitution is 0.5, which can be written as half. So square of half is 1 by 4. The height from which it was dropped was 20 meters. So 20 by 4 is 5 meters. So it will rise to a height of 5 meters. Moving on to the next question. Two discs. Two discs of same mass are made up of different materials such that their thicknesses are 1 cm and 0.5 cm respectively. The densities of materials are in the ratio this. The moment of inertia of these discs respectively about their diameters. So the body under consideration is a disc, and the axis under consideration is the diameter. Okay. So we know this moment of inertia about its own axis. I'll take it as y I1 as it is m r square by 2. We all know. Now, when we apply perpendicular axis theorem, then you will be getting the moment of inertia about any diameter as mr square by 4. So, this is the formula. Now, it is clearly given that they are made up of same mass. So, but their thicknesses and densities are different. Now, we can express the mass as volume into density. So, volume is pi r square into thickness into density. So now we can replace r square with m by pi t into rho. So replacing this here, we can write that the moment of inertia is m by 4 into r square is m by pi t rho. So as you can see that the required moment of inertia varies inversely as thickness into density. So therefore, the required moment of inertia, I'll take I1 by I2 as T2 by T1 into rho 2 by rho 1. Okay. So thicknesses are given 1 cm and 0.5 cm. So this will be 1 cm, this will be half cm. Densities are in the ratio 3:5. So finally we have 5 by 6. So the ratio is 5 by 6. So x is equal to 5. Okay, that's all in this students, in this channel students. Thank you so much.